Okay, so we just took test number 2. I will get that back to you as soon as possible. Today we cover operations on algebraic fractions. You can see that we have not 1 day on this subject, not 2 days on this subject, but 3 full days of basically doing the same thing, adding, subtracting, multiplying, and dividing fractions, all of which you know how to do when it's just numbers. But today we're going to take fractions that have x's in them, and we're going to add them and subtract them and multiply and divide them. That's the plan for the next 3 classes. And then the 4th class from now is more fraction stuff, but actually that's a day where we'll be solving equations using the tools that we built over the next 3 classes. And then after that 4th day of new material, we are done with new material for the semester. So we're really getting down to it here. So this May 13th, that is a week from today. So a week from today, we'll be done with the new material. On Friday, a week from this Friday, we have our 5th and final class that is only on the new material. Then Monday is the last day of classes, last day of the semester, and that's our review day for our final exam, which is coming up Wednesday the 20th. Exactly 2 weeks from today, this course will be done. Irene. You can talk to me if you have a conflict, and if you do, perhaps you could take it with Caitlin's class. Would that work for you? Okay, talk to me individually. Yeah, Caitlin and I don't have a policy set up, but maybe we can work something out. Okay, other questions? All right, so here we are again on page 188. We'll jump to the top with Cody for the daily summary. Okay, number 1, Irene. You don't need to read them. Go ahead and read the next part, though. Everybody understand what an algebraic fraction is? Those are 3 examples. You know the word fraction. Now it has x's in it. That makes it an algebraic fraction because we're going to be doing algebra on it. Lucas, number 2. Evaluate simplified operations. Okay, so number 3 says evaluate the following algebraic fractions for x equals 2 and x equals 5. Let's try these together. So let's substitute x equals 2 into this first fraction in part A. So it becomes 3 over, and I'm going to put parentheses, 3 over 2 squared, yes? And so that's 3 over 4. Go ahead and fill in the other thing in that first row, where we plug in x equals 5. 3/25 is good. Questions on evaluating? We can do the same thing in part B. Again, plug in x equals 2 and plug in x equals 5. Nothing to be frightened of. There's just a couple of different x's here, but they all become 2 or they all become 5, right? So when we plug in x equals 2, what do we get? 2 over 9 is good. When we plug in x equals 5. 5 over 12, everybody understand how to evaluate? And then the last one, x equals 2. What do we get down here? Let's see here. So we get 2, so I get a 6 over -3, yeah, which reduces to -2. Right, and Irene reduced that, which is something we're obligated to do. I'll write it as 6 over -3 first. And then that becomes -2. How about in the bottom right? 0. What do we get upstairs? 9. Downstairs? 0. What is that? Yeah, what is it? Is it 0? Is it 1? What is it? Is it a mystery? We have a word to describe this thing. It starts with the letter U. Undefined. That's what this is, right? This is undefined. It's not 0. It's not 1. It's not imaginary. It's not any number. It is just undefined. We're not allowed to divide by 0. Yeah. All right. 0 divided by any number is 0. but any number divided by 0 is undefined. And you could think of, like if you have pizza cut into 8 equal slices and you have 0 of those 8 slices, how much pizza do you have? 0 pizza, right? No pizza. So that makes sense. But if you tried to take your pizza and cut it into 0 slices and then make the claim that you have 8 out of those 0 slices, that doesn't make sense. Yeah? Okay, let's go to Jeremy. We see. Okay, so this is a new thing for us. Let's go to Will for number 4. Okay, so let's see. We're taking a look at that denominator. We'd really like to make sure that denominator is not equal to 0, right? Because we just discovered dividing by 0 is a bad thing. So what we'll do is we'll take it and we'll make it equal to 0, which is the opposite of what we just said. But we're not good at solving things not equal to 0, but we're really good at solving things equal to 0. And then whatever we get, we know are the bad guys. So we take that thing, we make it equal to 0. You can solve it with the quadratic formula. In this case, it's easier if you factor it. And if you factor it and eventually solve, you get these two numbers, x equals 3 and x equals -2. By virtue of how we got these numbers, what would happen if you plugged x equals 3 in there? You get 0. Okay, do it. Plug x equals 3 in there. What do you get? 3 squared minus 3 minus 6. Is it 0? Of course it's 0. I mean, that's how we built it, right? And likewise, if you plug -2 into the bottom, you would get 0. So is it a good thing or a bad thing to try plugging 3 and -2 into that fraction? It's not a good thing because we end up dividing by 0. So, typical test question is find values of the variable where something is not defined. Here's our answer. That fraction is not defined at x equals 3 and x equals -2. And the process is by setting the bottom equal to 0 and saying these are the bad guys. Okay, so that's the not defined part. Let's go to Savannah for 5. Okay, so we're going to do this in slow motion, but 24 over 54, if you wanted to, you could maybe divide both numbers by 2. Or you could divide both numbers by 3, or you could divide both numbers by 6, and you'll get your answer. We're going to do this in more detail than you would provide because it's going to lead somewhere good. So here it is written out. 24 over 54. We're going to factor both of those numbers. 24 is 6 times 4. 54 is 6 times 9. Agree? Now, there are other ways to factor those two numbers, but we chose this factorization because 6 is the largest thing that goes into both 24 and 54. And so do you then buy that we can split this up? Again, this is in slow motion here, but we can split it up into the product of two fractions. And if you're not sure why that's true, do you buy that we could go the other way? How do you multiply two fractions? You just go straight across. So 6 times 4 on top of 6 times 9. So they're equal. So let's go this way. And then 6 over 6 is really 1. And then 1 times 4/9 is just 4/9. And so all this is a long way to go to basically say, hey, just cancel the 6's, right? I mean, that's what you're doing, canceling the 6's. But like I said, it's going to go someplace good. So in the above calculation, we cross off the 6's because 6 over 6 is a fancy form of 1. This is a phrase that we're going to be using over and over again in the next few classes. But 6 over 6 is just a fancy way to write the number 1. And if you see a fancy way to write the number 1 and it's multiplied, then you don't even need to write it in the first place. So FFOO is our abbreviation for fancy form of 1. That is not really pronounceable, so we're going to make up a pronunciation. We're going to call it a foo-foo. Right? Fancy form of 1. Okay, on the next page, let's take a look at number 6. Are we allowed to cancel the 2's in these fractions? Let's take a look at part A. Are we allowed to cancel those 2's? I know. They are not directly over each other. So the question is that a problem? Because in the last example, they were directly over each other and we crossed them off. Lucas, you say not a problem? Why not? You guys buy 13 times 2 is the same as 2 times 13. We feel better now that they're on top of each other. So can we cancel them? We can. And so I'm glad Irene asked the question, because now we've discovered, hey, it doesn't need to be directly on top of each other. But as long as it's multiplication upstairs and multiplication downstairs, you can cancel things that are exactly the same as each other. And so this is really just equal to 13 over 3. Super. In part B, same idea, but we've got some addition. Same numbers. Can we cancel the 2's? Yes. So if we cancel the 2's, what do we get? 13 over 3, right? The question is allowed. Are we allowed to cancel the 2's? If we are, it isn't because of the same technique we just used, because the technique we just used on the previous page involved multiplication, not addition. So let's see whether or not we can cancel the 2's. I know what the right answer is to this problem. The right answer is 15 on top of 5. Yes? This is the right answer, which is just the number 3. Do we get the right answer if we cancel those 2's? No, we got 13 over 3, which is not 3. So are we allowed to cancel when there's addition? No. It is a specific to multiplication thing that allows us to cancel in A. In part C, I see some 2's, see some subtraction. It's tempting to cancel. Let's not invent rules here. Let's discover whether or not it's okay. What is the top, really? 11. The bottom? -1. So altogether, -11. If we cancel the 2's, what do we get? 13 over maybe -3. I don't know. I mean, you're not allowed to do it, so it hardly matters what you might get. It's definitely not -11, right? So again, I highlight the only way that we can cancel is if it's what operation? Multiplication, not addition, not subtraction, only multiplication. Division we will tackle by turning it into multiplication. So yes on division with a little bit of a twist. Okay, number 7. 7? No. Let's go to Marcy. 7. Okay, let's go to 8. Cody again. Okay, let's take a look at this guy, part A. X squared minus 9 over x squared plus 6x plus 9. We are going to reduce this thing. We are going to simplify this thing in the same way that we simplified, I think these were the numbers, 24 over 54. Is that it? Became 4 over 9, which is a simpler version of that fraction, yes? All we are going to do is exactly the same thing with this guy with x's in it. We are looking for a simpler version of that fraction with x's in it, something that is reduced. Now I'm tempted to cancel a whole lot of stuff in this fraction. I see x squared on top, I see x squared on the bottom. Cancel. I see 9 on top, I see 9 on the bottom. Cancel. Can I do that? No, because the only way we can cancel is if it's what operation? Multiplication, and this is not. So none of those things that look cancelable are. So what do? Well, we have to turn the subtraction upstairs and the addition downstairs into multiplication, because that's the only time we can cancel, is if we have multiplication. So how do we turn additions and subtractions into multiplication? We factor. So something we spent a lot of time on. It's factoring. Factoring turns something into multiplication, and that's a good thing as far as fractions are concerned. So the big question is, are the numerator and denominator in factored form? No, they are not. So if the answer is no, you cannot reduce until it is factored. Step 1 says factor the numerator and denominator completely. So let's do that here. So upstairs, I'm going to write 2 sets of empty parentheses. Upstairs is a particular kind of pattern. You could use the box, but we're going to save some time by recognizing this is a pattern. It's got two terms, it's got subtraction, and both of those things, the x squared and the minus 9, or the x squared and the 9, I should say, are perfect squares. You guys remember the difference of two squares pattern? So the difference of two squares pattern gives us an x plus 3 and an x minus 3. Okay, downstairs, x squared plus 6x plus 9. This is probably a box question. Some people take very little time with the box. Some people take more time. We're just going to write the answer and say, hey, if you use a box and however long it takes you, you'll eventually get to this. X plus 3 times x plus 3. So we're not going to spend our time together doing the box. You'll do it in the activity. So we're now in factored form, which means the main operation everywhere is what? It's multiplication. Now it's true, inside of the parentheses, I see additions and I see subtractions. But fundamentally, this is a multiplication up on top and a multiplication downstairs, right? If you just kind of like blur your eyes a little bit, don't get lost in the details in the parentheses. This is a multiplication on top and bottom. And because it's multiplication on top and bottom, I can cancel anything that's the same upstairs as downstairs. So what do you see is the same? X plus 3. So we cross off x plus 3 in both. That is just a fancy form of 1, and there's no need to write it. It makes the thing look more complicated than it really is. And then we will put our final answer here, x minus 3 over x plus 3. It's okay to put parentheses around it here. Typically, you would still need it, but because everything else disappeared, we don't need it. Questions on that one? Okay, part B, 3x plus 12 over 6x plus 24. Can I cancel 3 and 6? No. Can I cancel x? Can I cancel 12 and 24? Will, louder. The only way we can cancel is multiplication, and there is no multiplication here, so we cannot cancel. We are going to simplify. But first thing we need to do is factor top and bottom. This is going to be our first step on every one of these problems, is factor top and bottom. So factoring the top, this is one of those where there's a greatest common factor we can pull out. What goes into 3x and 12? 3. Go ahead and fill in the parentheses after we factor out that 3. Yes. Which ones? The 12 and the 24? Oh, ultimately, it is a half, and you're recognizing something very specific here, that the bottom guy is exactly double the top guy. What I want to do is make sure we see that it's a multiplication thing at heart. You're right, it's a half. Yeah, this one is a half. Okay, when we factor out the 3, what do we get? X plus 4, and then downstairs, factor out 6. Which, the 3 over 6, you mean? If we had 2x plus 8 down here, then we could have factored out another 2. Do you want to change it to 2x plus 7? Can you write down? I'm having a hard time understanding. Yeah, just write it down. I'll take a look. Okay, we now have multiplication. So we are now welcome to cancel any foo-foos, any fancy forms of 1. So what cancels in this case? X plus 4 cancels. And then 3 over 6 happens to also cancel. I don't need you to go through the process of, like factoring 3 and factoring 6, just to write the answer. What's the answer here? 1/2. Okay, let's take a look at the last one here. C, 2 plus x over 2. I really want to cancel those 2's. What do you think? Not going to happen. You guys are tough. One of these twos is actually ready to cancel. Which one of the twos is ready to be canceled? It's the one on the bottom, because the bottom, you can imagine, has a multiplication times 1. Right, the bottom is a multiplication, but the top is in addition. And so there's nothing ready to go on the top. So we are ready to then factor. Is there anything you can do to the top in terms of factoring? Put a 1 on the outside. It doesn't change anything. There's no factoring we can do upstairs. And if there's no factoring we can do and there's no canceling we can do, then this is simplified. Right? I think sometimes we write CBS or cannot be simplified. There's nothing to do. So just like with all those crazy laws of exponents, there's so many opportunities to do things that just aren't valid. And not only do you need to know how to do the right things, you also have to know when you're done and you can't do anything else, like in this one. Okay, so this is all about simplifying a single fraction. On the next page, we'll have a pattern and then some multiplication division. Okay, number 9, let's go to Irene. Okay, so let's try plugging x equals 10 first. 10 for all the x's. So 10 minus 3 over 3 minus 10. What is this equal to? That's 7 over negative 7, which is negative 1. Okay. Now let's plug in x equals negative 2, again, for both x's. Also negative 1. And it turns out, always negative 1. Doesn't matter what you plug in to x minus 3 over 3 minus x. Because you're subtracting the same exact numbers on top and bottom, right? Just in the other order. So do you buy that you're going to get the same number top and bottom, just one positive, one negative? Okay, so let's go to 10 for Lucas.
First expression below. Square. How about
okay, so let's take a look at this example. Can we cancel the x squareds? Nope, I see subtractions, not ready to cancel. How about the 64 and the 16? No. So we got a factor. 64 minus x squared is another difference of 2 squares. It becomes an 8 minus x and an 8 plus x. Downstairs is a box method. Again, we're going to save a little time here. I'm just going to say the answer is this. You will get there by using the box. Now here's the pattern. It's circled. 8 minus x over x minus 8. That is this a minus b over b minus a pattern. Do you see it? There's fundamental things happening to recognize that pattern. You got to have a fraction. You got to have 2 terms separated by what? Subtraction. Has to be a subtraction. So it's 2 things subtracted on top, exactly the same 2 things subtracted on the bottom, but in the other order. That's the pattern. A minus b over b minus a. And so the x minus 8 and the 8 minus x, they cancel, but they don't just cancel completely. They cancel and become what number? Negative 1. That's how they cancel. And so I'll highlight this guy, and they become this negative 1 that you can see sort of coming from out of nowhere. But you have to introduce that negative 1 when you cancel, and you just bring it in. And so that negative 1 in the front, I've just put as a solitary negative sign out in the front. So 8 plus x over x plus 2 with a negative sign in the front. Questions on that one? Okay, so it's just a new pattern for you to think about. Sometimes it's tempting to use the pattern even when we can't. Let's take a look at number 11. X plus 5, x minus 1, x minus 7, 1 plus x. Do you see the pattern? A minus b over b minus a? If we do see it, where is it? Which 2 factors here? Right, that sure looks like the pattern, right? X minus 1, 1 plus x. But it has to be subtraction. This is not the pattern. I didn't trick you. I'm just sharing with you that sometimes you'll see something that looks like the pattern and isn't the pattern. The pattern has to involve two subtractions. 1 plus x will never be part of the pattern because it's not a subtraction. So we can't do anything with that. Okay, number 12. Let's go to Jeremy. Let's pause right there before we read the answer. Do we remember how to divide two fractions? With reciprocal, right? Which one gets copied? First one or the second one gets copied? Which one gets copied? First one gets copied, then division becomes multiplication, and the second one gets flipped or reciprocaled, right? And so it's written out here, 4/9 divided by 2/27. We copy the first 4/9. Division becomes multiplication, and at that same moment, 2/27 flips over to 27/2. And then how do we multiply fractions? Yeah, like you could just multiply straight across, but Alex has the right idea. We want to simplify first. So in this case, 4 and 2 become just a 2 and a 1. How about the 27 and the 9? It's a 3 and a 1. And so upstairs we just have 2 times 3 is 6. Downstairs 1 times 1 is 1. So we just get 6/1 or 6. Okay? So this is old. In number 13 is new. So here we're going to multiply some algebraic fractions. Part A, 15x to the 9, y to the third, times 2/35x to the 4, y to the 10. Okay, first thing I'm going to do is make this look like a fraction by putting it over. Okay, and now that it's over 1, I'm going to start reducing anything that I see from either fraction, right? Take a look at the 27 and the 9. They were not both in the same fraction, yes? They were in different fractions, but we had no problem saying, hey, it's okay, they're in different fractions, we can cancel them. So anything from the one numerator canceling with the other denominator is fine. So for example, 15 and 35 become, 5 goes into both and becomes 3 and 7. Let's think about the x's. There's more on top, so when I cancel these x's, there will be x's left over on top. How many will be left over? Alex says 5. Other thoughts? Is that right? Because we know we're supposed to do what with these powers here? We subtract them. Okay, so upstairs is really x to the 5. Downstairs, you don't need to put it, but I'll put a 1 there as my placeholder. Same idea with the y's. How many y's left over? Yeah, you could call it -7. I really like positive exponents at the end. So how about we say +7, but where will those y's live? On the bottom, because there's more down there. So this guy on the bottom becomes y to the 7. This guy on the top, I'll just change it to a 1. So you got to make sure that you don't lose points because you can't read what you just wrote. And it's sometimes easy to write things too small and too clustered that you kind of lose track of stuff. So just be really careful when you write this out. So if you can see clearly everything that's left on top, just multiply it all out and we'll have our final answer. So upstairs, the 3 and the 2 are the only things we can smush. So I get 6x to the 5th over 7 y to the 7. That's it. Easy? Okay, let's take a look at part B, which is a little bit more frightening than part A. So first thing I recognize is this is a division problem. And so I know how to handle a division problem, and that's to turn it into multiplication. So first fraction, copy or flip. Copy the first one, just as it is. Division becomes multiplication. Second fraction, copy or flip. Flip. All right. Okay, I'm ready to cancel. For example, can we cancel y squared and y squared? They are in the same fraction. It's okay to cancel in the same fraction, but what's the issue with the y squared? Yeah, it's not multiplication. Maybe that's what you meant when you said like terms. Not multiplication. So we can't cancel those. How about what? How about this y right here and this y right there? No, not multiplication. How about 2 and 2? Oh, not multiplication. So before we do any canceling, what do we need to do? Factor. We got to factor. So let's factor. Okay, I'm just going to zip to the answer here. Again, you can take your time with this when you're working in the activity and in the homework. That first guy is another difference of two squares. It becomes 2y plus 1 times 2y minus 1. Irene? What format? Often it will be two parentheses. If it's a difference of two squares, yes, it's always the two parentheses and the plus or minus. I'll write it out up here. A squared minus b squared, I think, were the letters that we used. And it became a plus b and a minus b. Okay, downstairs, 4 minus y squared is yet another difference of two squares. 2 plus y, 2 minus y. By the way, at this early stage, are any of those things cancelable now that we've factored? Are any of them exactly the same as each other? No, there are parts that look similar, but none of those are the same. None of those are going to cancel with each other. Okay, up on the top, different kind of factoring for y squared minus 2y. What's the greatest common factor that we can pull out? There's a y, and then we're left with y minus 2. Downstairs, what's the greatest common factor we can pull out? 2, and we're left with 2y plus 1. And then you cancel all of those foo-foos. Any fancy form of 1, you cross off. So go ahead and cross off all the things that are exactly the same as each other. What did we find that we can cancel? 2y plus 1, 1 there, 1 there. Anything else? 2 minus y and y minus 2. That's not exactly the same, but it's that a minus b, b minus a pattern. Remember this one? So 2 minus y, y minus 2. I'm going to just put that as a times negative 1. I chose to put the minus 1 upstairs. You could choose to put the minus 1 downstairs. Ultimately, that minus 1 for me is going to go in the front, so it hardly matters where you put it. But you're only putting one of them. This is a moment where you could make a mistake. If you put a minus 1 upstairs and downstairs, what have you really accomplished? Nothing, right? Because a minus 1 up on top and down the bottom would become positive 1 when all is said and done. So just a single negative 1 really any place will. We did use on the right side. Okay, so I think you're asking about pulling out the greatest common factor as opposed to the box method. So the greatest common factor is always the first thing I look for before I think about the box. So I didn't say anything, but the first thing I did when I saw this was decide, oh, there's nothing I can take out of both terms. Right, but it's always the first thing to look for. Good question. Okay, so then I think we are done. Is there anything else that we can cancel? I see a 2 on top and some 2's on the bottom. No canceling? No, they don't look exactly the same as each other. So then just carefully write down our final answer. Like I said, I'm going to take that green negative 1 and just write it in the front of the entire fraction. Upstairs, what do we have? I'm going to leave it in factored form. You're totally welcome to do what Alex did, which was distribute that y through. Downstairs, again, I'm going to leave it in factored form. And again, you're welcome to multiply through if you wish. Correct.
So that's the point.
Right.
Now, if you put the negative one on the bottom, it still does the same thing.
Yeah. So instead of that -1 being right there, I could have decided it was going to be up there. That's a full credit correct answer. I could have put it down in the bottom. That's a full credit correct answer. But typically, if a fraction is negative, we tell the reader right away, hey, this is a negative fraction, and we put it first. Irene? Yes. I can put the y and the 2 in the front. I'm with you. Okay, so the main point for today, factor first. Got to factor. Lots of things will look cancelable that aren't. Factor first. Okay, skip 2 pages and you will find the activity raise the flag if I can help.